Okay, we're down here on my day off working, playing around with my junk. Nice hot night tonight, Sunday. About 9 o'clock right now. So I spent all day wasting time helping customers on my day off. And I also deburred all my plates here I cut off a month or so back. So these are some 1-inch steel plates here. So I cut them off to my casters. So these are my casters for my big A-frame to pull my motor and my cab off my truck outside. We're disc stripping. So these are some big military casters. So I gotta make some holes here to hold this all on here with. And I'll weld these plates to the bottom of my A-frame. My cast will be removable. So this is one I just got done doing. So that's the first hole I did here. This one here I did it with one size bigger drill than what I should have, because I didn't know how easy it was going to be to tap this. So you see how loose this bolt is. Even when you're all the way down as far as it's going to go in the plate, which would be about here. The plate's about 1/4 inch thick, plus the lock washer. It's going to be about here probably. You can see how loose it is. Okay, these other three I did the stock size hole. So you can see how the threads are more pointed, because the hole through the center is bigger. So when you do that, then the bolt's a lot tighter. Hear it? It's different. So when you get them down to where they belong, there's almost no play down here, whereas this one's still pretty loose. Now you pull this one out a little bit, it'll get looser. And it's still not as loose as this one is here. Only a couple threads. They're about that far, it's about the same. So this one's only got a couple threads holding it. It's as loose as this one, and it gets looser. Alright, so that's how we do that. So we're going to go ahead and show you how we do all this. Now, I cut the plates all off the same size, so I got the same dimensions I'm using up here. Basically what I do is I come off the center point right here, and I just go X and Y, boom, 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 boom. So it's this dimension each time, 3 3/4 by 3. So it's 3-inch offset this way, and it's 3 3/4 this way. And just one's plus, one's negative. If you come off the center plate, center of a part, you only have to memorize 2 numbers, your X and Y, and it's the same each time, or at least on a 4-bolt pattern. If you did dimension off the side, then every number will be different. You have to remember each one of the 4 numbers. A little bit harder. So, we haven't tried to see if this fits on here yet, but it should fit right there when we're done. We'll find out when we get this off. Okay. I'm ready to clean the chips up, so it shouldn't be too much underneath. Be a little bit, but not too bad probably. So I'm going to do 3 more of these, 4 casters all together. Then I got to rebuild the casters. That'll be the next project to do. Nice and light. I still got to deburr this side here, right here still. Figure how I'm going to do that. First thing I do is drop the thing over here so I have to deal with it. Alright, so then we want to deburr these a little bit. Usually I'll use something like this. And it looks like this would probably work for that. It's just a 3/4 inch ball burr carbide. You can also use a big drill bit. I don't have a big drill bit. I can use on my drill motor anyway. So let's see how this works. Camera's in my way. Gotta keep the RPM down for chattering. Find the right load, the right RPM, a decent finish. Alright, those look good. Take the file, knock off the high spots. See the chip still attached right there. That's not a good sign for deburring. Alright. Okay, that'll be the side that welds up next to the plate. This will be the side that goes next to our caster wheel. Right there. Alright. Appears pretty good. This one's tight. It's not the plate, it's the threads. Might be the bolt. Yeah. Combination. Form fitting. Knock the burrs off. There's some junk in the threads there probably. Alright, well, obviously the caster's going to work. It's got about a 50-pound caster, solid steel wheel, about 3-inch wide by this big around that goes on here. These are heavy-duty casters. There's big balls that go right here. They're probably 1/2 inch or 5/8, probably 5/8 balls that go in here. Pretty heavy-duty unit. So anyway, heavy-duty. So we have to have heavy-duty plate to make it all work. All right, so that works good. So I'm gonna get these out of our way. Go and get the next one going. So I'm gonna go over here. Back on top of our plates here. Eyeball it halfway close. That's a little easier to set up. And the spacers have to be in the right spot because we drill holes right through the center of them. Make sure you got to put them in the right spot. Alright. Okay, tighten the center one down the most. This one a little bit more. And these two here, I just put tension on them. Now we're going to hit it with a hammer right here. It'll pivot off this back bolt. So this whole thing will move so I can center it quicker. A little easier. Okay, first thing I'm going to do is give it a drill chuck. Okay, now I get to center it all up. Hammer. Indicator. Okay, so just put on 5 on my indicator. Right there. Now we just move the table that way and knock until the indicator quits moving. Pretty straight. So it looks like my eyeballs are within about 3 thou. Not bad. Okay, we're on 4.5 now. See what it goes to. About between 4 and 5. There you go, that's pretty quick. Was that lucky or good? I call it being good. Okay. Alright, now that centers up our plate. So now it's just a matter of finding our center point. Now this is already set up for the long dimension. From here to here. Eyeball it. Okay, now we just bring our indicator down. So we touch our plate here. Looks like I missed it by about 30. Okay, needle straight up and down right now. Up and down, see how much it changes. Pretty close. Turn 180. We'll check our other side. And looks like we're off by quite a bit. A little more. Indicator's maxed out. Okay, we're on 40 right now. Over here, I'll check it again. Hard to see in the back. Looks pretty close. Okay, it looks like we put the plate back on the table within 16 thou where we started. So right there, 16. So zero that out. So now we're going to do this next number here. We're 149 off right now. So we're going to do the same thing, but now we're going to do it the other axis. So now we got the center point going this way. That's our X. Now we're going to do our Y axis, which is this way. So this one's narrower this way, so we have to move the indicator in a little bit. Of course, it wants to bother me on Sunday night. Hello. Yo. Yep, I'm working. Oh, hour 3. Okay, I'll be here. All right. Yep. Perfect. Okay, see you in a little bit. Bye. Yeah, more late night stuff. Oh, I can't even see the indicator now. Where's it at? So it's pinned. Nope, it's not even touching Mr. Corbett. Back on this side. Oh, that's not good. Oh, banging the tip in. Not good for your indicator. You rotate until the lowest point. It's right there. So we got 0 to 5, 10 going up. We're not even touching this way yet. Okay, pretty close now. Get the indicator to read. Okay, 0 to 8 or so. This is a taper cut. Alright, about the same, 5 or so on that side. It was over here, so yeah, 5 or 6, it was pretty even though, with a couple thou. So we're center. So we're 38 thou difference this way. Okay, so now we're zeroed out. So we got a dead center right now, which we're not going to use for anything for cutting a hole, but we're going to base our dimensions off of it. Okay. Oh, got my trail chuck back in there. Hard to work without holding into. Alright, now we can hold our parts in there. Okay, it doesn't matter where you start at, so I'm going to go back like I did before. I'm going to start over here. This one's 3 inches. Right there, a couple tenths off. And the other one's 3/750. 3/4 of an inch. There we go. Alright, so now we're up there. See that in the camera there. Okay, so that's coming off our center point, 3 3/4 this way, 3 inches this way, puts us where we want to be. Okay, now we can go ahead and drill our hole and make a mess. Alright, I think we can have the camera here without being too much in the way. Okay, so now we're just going to put our center drill in here. I'm going to change my speed as I go. I'm going to start about 750 RPM, we'll drop down to almost 600 time we're done. There's 800, close enough. Once the big part starts cutting, we slow it down. It doesn't burn up as much. I always like burning up my tools, but cutting thick steel plate, I slow the speeds down. Okay, this is the drill we're going to use. I hand sharpened this earlier so it would cut. I cut the side back a little bit. And cutting edge there, and I recut the top too. So surprisingly, it cuts better than it did when I started. I don't know how that happened. But we got lucky again. You can hand sharpen stuff as long as you know angles. You want to make sure you always have a leading angle and not a negative angle. Negative angle means you rub on the back side. Positive angle means you cut on the front edge where you want to cut at. So on regular soft metals you don't want to have any negatives. So this is like a knife blade on the front. You got clearance on the back side. There's also a radial dimension going the other way, but that's kind of preset a little bit. Now this is just a hand chuck for tightening. It's a really high quality one, so I can do pretty good stuff. Like power a 5/8 tap by holding it with that. Gotta have a good chuck to do that. Okay, this time we're going to slow our speeds way down on this one. So I'm drilling at about 250, 300 right in that area. There we go. A little oil because it's part of steel. Look here and set my depth stop so I don't go too deep. Give ourselves a little more than a quarter. About 1.25 inches. Got 1-inch material, 1/4 inch pop through. That way I don't drill into my table. I don't like my table having drill marks in it. I've only done it a couple times. 75 RPM, let's speed it up a little bit. 175. 210's what I was using. That's a nice chip, not blue, warm. Hot on my fingers. Now we'll cut through the hole all the way out. Kind of twitch my arm to take cutting pressure off. Keeps the chip short, so they don't get too long like this. Going through the hole now. Light pressure when you go through. I'm not turning the blue this time. Oh. I was like making my chips blue. Blue or purple. And these are getting really hot. If I was going to higher speed, I couldn't pick these chips up yet to be burning my fingers. There'd be smoke coming off of my fingers. Okay, to chamfer the hole, I just use a big drill. About that big. Turn the speed way down. Crank the table up. So I get my exercise. Alright. So I just come down and lightly chamfer with a big drill. Turn the speed down. 100 works good. Here's 100. About that much. On a big hole, a big drill works good for chamfers. Okay, now we got our tap. Bring it up. Pull the depth stop out. Okay, so right now we need more clearance right here because the tap down here is more than what that is. So I got to crank the table up over here to get it up higher. Down here, this big thing. Okay, so the tap's touching this plate. We have a good clearance up in here, so we won't bottom out. I already know my dimension. If I don't go past the last 2 threads of tap, I won't hit the table below me, like I did the first time. When you hear the machine starting to labor and it's picking this plate up off the table, even though you got clamps on it, you know you got a good load on it. Yeah, the machine at lower RPM has a lot of torque. I'm cutting at about 70 RPM, 75. A lot of torque. 5 or so. And just power it right on through. It'd be hard to press to do this by hand. And then just went through. Reverse it. Now a 3-phase power motor up here, you can reverse it instantly and you got full torque backwards right off within a quarter turn. Otherwise you just couldn't use this full power of the machine. Now this jams in there so much you can't do this by hand very easily. So I cheat, use water pump pliers. So you want to make sure you don't slip or you tear up your damn tool. And the next time you go use it, it tears up your hand. So there's our tap. Keep it well lubed and RPM down, it doesn't tear it up too much. But I like cutting fast, that's my problem. Okay, so now that hole is done. I'm going to check a bolt here just to make sure it's good. Appears to be good. So there you go. Simple. I can do it 3 more times on this plate. And I got 2 more plates to do after this one. So right now we got our dimension up here. So we go to 3 inches the other way. And it doesn't move anywhere else. Or we didn't change it to our x-axis. So it makes it nice when you're doing this. So the holes are precision laid out. And it's pretty quick to do. And you only got to remember 2 numbers, so it doesn't take too much to do it. And our next hole. Change our speeds back around and punch it in there. Chip started going yellow there because I got the speed up to, I went up to 1,000 RPM there. I cranked the drain wheel up there too much. That'll be the speed controller. Okay, we got that. We'll get our big drill again. Of course, we got to drop the table down again. See, I have a manual power system here, so it's me. See, I'm not hot enough yet, so I'm going to work up a sweat here. Okay, you get in the right spot. You put the drill in, you got clearance. Okay, I'll just do this again. Change your speed. Already back to topping again. I'm going to go up that high. Actually, this is a lot of exercise. Cranked my table here by accident. Nailed it. Alright. Alright, that's enough. Okay. Working up a sweat for some reason. It's hot, humid day, night and day. California's burning again. A little bit better than it was yesterday though. A couple of fires are out, more or less. Alright. Let's power this one in. Right direction helps. Go at speed. Just keep light tension on your crank up here to pull the top. Repetitive work. Well, you do the same thing every time. It's not too hard. I didn't clean the table off though. Forgot to. Chips are too hot. How about that excuse? Is that a good excuse? Okay, now we got the next one. Alright. 7.5. 7.50. Oh, right on the money. Okay, I'm going to do another one. Gear wheel. Center drill, the small part, likes being fast. This doesn't cut very good at 600 RPM. It's got like a 3/16 first cut on it, so it wants to be more like 800 RPM. 750, 800, all of a sudden it starts to cut. And then when you get to the bigger part, it goes up to 7/16 of an inch. That doesn't like that RPM, it starts making blue chips. So you want to slow that down to 600 RPM. It's a variable speed drill. If you got to vary the speed, not it. Alright, now we have to drop the table back down. So this is repetitive work. Alright. Can't see anything over that view. Let me get over here. I can see again. Okay. This time I got to set the depth stop that I forgot to do before. That'll be good enough. I made the chips longer that time. I wasn't paying attention. Just watching the camera. Someone left a comment that my camera action sucks when I use one hand. I didn't see them volunteering to help. Oh well. Okay. Crank this up. See, I blocked the camera and crank faster. See, the drill works really nice for doing those chamfers. That's nice, clean. Don't cause any problems. All my other countersinks for doing that suck, don't work. Burr the hole up. These don't work. Try lots of styles, single point, double point, 8 point, flute, whatever. Drill works the best. Okay, I gotta crank her up some more. There we go. That's enough. Alright. Good. That's too quick. Not enough time to rest between the holes. It's becoming almost work now. See, the first 5 is just playing around. After that, it turns into work. I'm up to 7 now. Okay, well, I'm going to finish this plate up. And I got 2 more to go after that. Got these ones over here to do. Got to do 4 of them. So we'll be back later. Unless you want to watch repetitive motion lots of times. I don't think so. That's it for now.